Welcome to qnawire.
All right, so we've got pent 1-ene. And the question is, will this show cis-trans or easy isomerism? And I would say no, right? Because for that to be the case, we need to have two different substituents on both sides of our double bond. In the case of pent 1-ene, one side of our double bond has the same substituent twice, right? So there can't be any easy isomerism. Right? Okay, now let's look at B, which is pent 2-ene. Okay, now we're in business, right? Because on either side of this double bond, we've got a methyl and a hydrogen, as well as a hydrogen and a ethyl. So now we've got two different things on either side. We can definitely have cis-trans isomerism. So here we've got the trans version because the highest priority groups, the methyl and the ethyl, are on opposite sides of the double bond. Okay, so that is trans, which we can also say is E, German for entgegen or opposite, because they're on opposite sides of the double bond. And if we want to draw the cis or Z version, we simply swap the hydrogen and the ethyl, like so. And now we've got cis/Z. Okay. Next, we've got hex 3-ene. Okay. And what have we got on either side of this double bond? We've got an ethyl group and a hydrogen on either side. And yeah, as long as on both sides we have two unique things, it doesn't matter that these are both ethyls or these are both hydrogens. All that matters is that we've got hydrogen and ethyl on one side and hydrogen and ethyl on the other. It's not hydrogen or ethyl. So this would be the trans or E version, right? Because the ethyl groups are on opposite sides. And then if we want to draw the cis version, we simply swap the hydrogen and the ethyl group. So this would be cis or Z. Stands for zusammen, which is German for same, as in same side. Okay. Next, we've got 1,1-dibromopropene. Okay. And look, we've got bromine here, bromine here. That's two bromines on one side of the double bond, which means this can't have cis-trans isomerism. Okay, now we've got 1,2-dibromopropene. And all of a sudden, yes, we can have cis-trans isomerism, right? Because on one side we've got bromine and hydrogen, those are different. The other side we've got bromine and methyl, those are different from each other. So we're good to go. What I've drawn here is indeed the cis or Z version because the bromines are on the same side. The bromine is the highest priority on the right-hand side. It's the highest priority on the left-hand side. And if they're on the same side of the double bond, then this would be cis, and the trans version would simply be I will switch the bromine and the hydrogen on the right-hand side. So this will be trans, and it will be E. Okay. Finally, we've got 1-bromo, 1-chlorohexa, 1,3-diene. Hexa. And we've got a 1,3-diene, so double bond here and a double bond here. And we've got 1-bromo, 1-chloro. And can we have cis-trans isomerism here? Certainly, right? Here we've got hydrogen and a chain on the right-hand side, a chlorine and a bromine on the right-hand side. So that double bond has cis-trans isomerism. What about over here? Yeah, we've got an ethyl and hydrogen on one side and a hydrogen and a long chain on the other. So definitely we can have cis-trans isomerism there. In fact, since we can have it at both versions, there are going to be a few different ways we can draw this, right? So currently, what do we have? Bromine is higher priority than chlorine, right? So this is, now the thing is when we have multiple double bonds that each have possible cis-trans isomers, and we can no longer use cis or trans because the molecule as a whole can't be cis or trans. We've got to refer to each double bond individually, right? So this one is Z because the bromines are on the same. The bromine is on the same side as the higher priority carbon chain on the right hand side, and on this side we're looking at this chain versus this chain. These are on opposite sides, so we're E over here. Okay, so we're going to draw the same thing, but we're going to swap the chlorine and the bromine to see what the E version looks like. Now we got bromine here and chlorine here. That means this is E, and I didn't change anything over here, so this is still E. All right, now we're going to leave the left-hand side the same as when I first drew it, so chlorine here and bromine here. But now I'm going to change this side, so we're going to swap the hydrogen and the chain. So now it's Z over here and Z over here. I'm going to draw it one more time where I've changed the left-hand double bond with the chlorine and the bromine. Bromine here, chlorine here, and I've also changed the right-hand side. Right, so now we've got E over here, and we've got Z over here.